All right, today we are diving into something truly radical. It's an experiment from OpenAI that I think could fundamentally change how we all build software. The challenge they set for themselves was this: could they ship a real working product without a single line of code written by a human? Let's see how they did it.
And they were serious about this. This was the absolute core rule of the whole project. Not just some of the code, not even most of the code. We're talking every single line. From the app logic to the tests to the documentation, everything had to be written by their AI agent Codex. No human hands were allowed to touch the code directly.
So what was the result of this 5-month experiment? Well, get this. They ended up with a product that's actually used by hundreds of people, with a code base of over 1 million lines. And they built it in an estimated 1/10 of the time it would have taken a normal team. I mean, that's just staggering. This wasn't just about a speed boost. It was about discovering a completely new way of working.
And that brings us to the central question the OpenAI team was really trying to answer. What does happen when engineers stop being coders? It forced them to rethink the entire software development process, literally from the ground up. So let's follow along on their journey and see what they found out.
Okay, so picture this. The team started with nothing, a completely empty code repository. Over the next 5 months, a tiny team, just 3 engineers to start, then 7, guided the Codex agent to build this incredibly complex application. Remember, they weren't writing code. They were more like directors, giving high-level instructions while the agent did all the heavy lifting.
So, the first big problem they ran into wasn't about the AI's power. It was powerful for sure. The problem was that it needed direction, a lot of it. The team realized pretty quickly that their jobs had to totally change. They weren't the builders anymore. No, they were the architects, the guides. Basically, they were the ones responsible for setting up the environment so the agent could do its best work. And out of this realization, a whole new role started to take shape: the harness engineer. Now, their primary job isn't writing application code. Instead, it's all about designing the systems that let the AI produce good code reliably. You can kind of think of it as building the entire racetrack and the pit crew, not just driving the race car.
And this really shows you how different the day-to-day work is. A traditional engineer, right? They're in the weeds writing code, fixing bugs directly. But a harness engineer, they step back and ask a different question. They ask, what tool or piece of information is the agent missing that would let it fix this bug by itself? It's a huge mental shift from doing the work to enabling the work at a massive scale.
And I think this quote really nails it. The big takeaway here is that this isn't about replacing engineers. It's about elevating their work. Their focus moves away from tiny implementation details and toward creating these systems that provide incredible leverage, where one single human prompt can result in thousands of lines of perfectly correct code.
Okay, but this new way of working created a whole new massive problem. With 1 million lines of code and growing, how on earth could the AI possibly understand the entire project? You can't just feed it everything at once, that's impossible. So the team had to figure out how to solve this giant context problem.
So their first attempt was, exactly what you might expect. They tried to write a giant instruction manual for the agent, this one huge file explaining everything, and it failed. It failed spectacularly. It became outdated almost immediately, and it just completely overwhelmed the agent with information. But then they had a breakthrough. They realized they didn't need a manual. What they needed was a map.
This idea pretty much became their guiding principle. Instead of just throwing a wall of text at the agent, they gave it a high-level guide, a map that had pointers to more detailed information. This was a game changer because it let the agent navigate the codebase intelligently, pulling in only the specific context it needed for the task at hand. And here's what that map actually looks like. It's not some abstract concept, it's a set of structured documents checked right into the code repository itself. You've got architecture diagrams, design principles, even plans for future work. Basically, everything an engineer or an agent would need to understand the project is living and version controlled right alongside the code.
And this all leads to a brand new design goal, which they call agent legibility. The team had this crucial realization. From the agent's point of view, any information that lives outside the repository, in a Google Doc or a Slack message or just in someone's head, it might as well not exist. So the repository itself had to become the ultimate source of truth, and it had to be organized specifically for an AI to read it.
So at this point, the agent is fast and it has a map to find its way around. But all that speed creates a new danger. How do you stop it from just creating a gigantic architectural mess?
How do you maintain quality and, taste when code is being generated way faster than any human could ever hope to review it?
Well, the answer was to enforce the rules automatically, mechanically. They defined a super rigid architecture with these fixed layers, and then they built custom tools to enforce those rules. And get this, the agent itself wrote many of these tools, these linters. The error messages were even designed to tell the agent exactly how to fix its own mistakes.
Now, to handle that inevitable messiness and technical debt that creeps in, they came up with this brilliant process they call AI garbage collection. They have these background agents constantly scanning the codebase, looking for code that violates their golden principles. And when they find some, they automatically open up pull requests to clean things up. It's like having a continuous, automated team dedicated to paying down tech debt.
So the key, really, was creating these strong, automated guardrails. As long as the agent stayed within those boundaries, it had total freedom. But the boundaries themselves, absolutely non-negotiable. And this is what allowed them to get that incredible speed without letting the whole foundation of the project crumble. So with all these pieces finally in place, you've got the harness engineer role, the repository map, the automated guardrails, the system crossed this amazing threshold. It started to become genuinely autonomous. I mean, just check out this workflow. A human being can now provide a single prompt just describing a bug. From there, the agent can reproduce it and even record a video of the failure. Then it implements a fix, validates that fix by actually driving the app's user interface, records a new video showing that it's all resolved, and then, this is the incredible part, it opens, manages, and merges its own pull request. I mean, that is end-to-end. It's almost entirely autonomous.
So, what are the huge lessons here? What does this new world look like? Well, first, the engineer's job shifts to system design. Second, the code repository becomes the absolute single source of truth for everything. And third, in a world where agents work this fast, it actually becomes more expensive to wait and block a change than it is to just let it through and make a quick correction later if you need to.
This quote really just sums the whole thing up perfectly. The hardest problems in software development are no longer about writing clever bits of code or managing complex logic. In this new agent-first world, the most difficult and the most valuable work is designing the systems that guide and control the agents. Which, of course, brings us to the final big question. If AI agents are going to be the ones writing the code, what is the most important thing left for humans to build? Well, I think this experiment from OpenAI gives us a really powerful answer. Humans build the harness. We build the environment, the feedback loops, and we encode our taste into the tools. As this tech continues to evolve, the very definition of what it means to be a software engineer is going to keep changing.